drag. All right, there's two kinds of drag. There's viscous drag and there's pressure drag. And both have an associated force. And so the force for each of these is going to be in the opposite direction of the motion of some object that's moving in a fluid or substance. So, for example, viscous drag is when you have an object that's moving in some really sticky viscous fluid like honey or some sort of green sludge like I have shown here. And the reason why there's this viscous drag force backward is because the object has to carry along some of this sticky fluid along with it. It kind of sticks to it. And so this drag force is going to be proportional to the viscosity times the velocity of the object times some length scale, which might be, say, the radius of this ball, if it's a ball. And, there might be some more details to this equation because it's a proportionality here, but if you want to get specific, there could be a coefficient that depends on some of the details of the shape of the object, but those would be given in a problem if you saw them in a problem. Then pressure drag. Okay, so pressure drag occurs because when an object is moving in some substance that isn't necessarily viscous, there's still a buildup of the substance in front of the object as it moves. And so there's a higher pressure in front of the object and a lower pressure behind the object, and that creates a drag force backward also. And so the drag force, the pressure drag force, is equal to 1/2 some coefficient of drag that depends on the shape of the object, and then times the density of the substance times the cross-sectional area of the object times the velocity squared. And that's drag.